Good day. Welcome back to lesson 5 of grade 12 inverse functions. In this lesson, we're going to look at the restrictions on a parabola. The inverse of a parabola is not a function. You will remember that from our second lesson. So what's going to happen is we're going to restrict the domain of the parabola so that the inverse will be a function. So let's look at the first problem. In this problem, they say to us that there's a function given, fx equal to x squared. You will remember this as our basic parabola with turning point at 0, 0. And then given to us a restriction. They say x must be greater or equal to 0. You will remember that the domain of a parabola is always the real numbers. But now they restrict this parabola only to the positive arm of the parabola. And they ask us to write down the range. Now, if I can just quickly show you on a little drawing how this will look like, then this parabola f will look something like that. So this is our f. Now, as you can see, this graph is restricted for x greater equal to 0. You will remember the parabola normally has got another arm on the negative side of the x-axis. But now we're only going to work with this positive arm. And our first question is that they want us to write down the range of this parabola now, this restricted one. So let's just look at how we're going to do that. So as you can see now that the domain of this one are those x values. So that means that x greater equal to 0, that is the domain of this one. So we are looking for the range, and that will be the range. So to write it down, we're going to first of all say that our function we're going to look at is this fx equal to x squared, where x is greater equal to 0. Now, as you know, that x squared is never negative. Because if you look at the drawing as well, you will see there's nothing below the x-axis. So this function is never negative. So what will the range then be? So we can then say the range will be all y values greater equal to 0. Also the equal part of the range, because of the domain also included the equal as well. In the second question, they ask us to find the equation of the inverse of f. Now, we've done a few of these questions, so we're going to follow the same approach. So I'm going to say that for f, that is y equal to x squared, that is the f function. And then for the inverse, we interchange and we say that x is equal to y squared. And now we manipulate and find y, and you will agree we find the square root on both sides. So we say plus minus the square root of x. So that is the inverse. But this inverse, plus minus root of x, you'll remember from lesson 2, we said that this inverse is the sideways parabola here. But now we don't work with the full parabola. We only work with a part of it, only one of the arms. So that means the inverse will also only be a part of that one. And therefore we can say it will also be the positive arm. And we can therefore say that the inverse of f of x is then positive square root of x. You may write the positive or just leave it out. but it will only be for the positive square root. And the reason is because y is always greater or equal to 0. So that is the B part of this question. So let's now look at C. In C, they say that they want us to sketch the graphs of f as well as the inverse of f on the same set of axes and show the line of symmetry. Now, we've done a few of them, so let's just do it now for these restricted parabola. And we're going to say fx is equal to x squared. And remember, x greater or equal to 0. And then the inverse function is what we said, the positive square root of x. Now, I'm going to follow the same approach. I'm going to substitute a few x values and work out the y value. And I'm going to do it for function f. And then you'll remember that for the inverse, we just swap those coordinates around. So I'm going to start with x equal to 0. And if I substitute x with 0, my y will also be 0. I'm then going to substitute x with 1, and 1 squared stays 1. And then I'm going to substitute x with 2, and 2 squared will give you 4. You will notice that I didn't use -1 for x, and the reason is because of the restriction. There is no graph on the negative side of the x-axis, so we can only work with 0 and positive values. So these 3 points we're going to plot, and we're going to draw it. But before we do so, let's just now find the coordinates of the inverse. And that is quite easy because we will just interchange them. The first two will stay the same, but the third one will become 4 and 2. So let's just now plot them and draw this. My first point I want to plot is the point 0, 0, right here. Then 1 and 1, and then 2 and 4. And you can already see where this restricted parabola will be. You see it's only that arm. So let's draw that quickly. So now you can see the drawing of f. As you can see, like I said before, it's only one of the arms of the parabola because we restricted this parabola because we want the inverse to be a function as well. Let's now plot these points, and they are the points on the inverse of f. So I'm going to plot those points. It's also 0, 0. It will also go via 1, 1, but then the third point will be 4 and 2. And you can now see that this graph will go right here. And that is half of the sideways parabola, only the one arm. So let's just draw that graph. So there you now can see the drawing of the inverse, and they also ask us to show the line of symmetry. And you still remember line of symmetry? That's the line y equal to x, and that is the line that will go right past these 2 points of intersection. So let's just draw that line of symmetry. And there you can see the line y equal to x, and we always write down the equation of this line on it. So there we've done the graphs. The graph of f, the inverse, and the line of symmetry. Let's look at D. In D, they say that G is the reflection of f in the y-axis. So remember, function f is this one, the one with the restriction, the x greater equal to 0, that is f. Now they want us to reflect this f in the y-axis, and I hope you agree with me, it will be here. So we need to do that reflection. So let's just do that and see what we get. So I will say that for f, it is y equal to x squared. And please remember that x is greater equal to 0, and y will also be greater equal to 0. That is the domain and range of f. Now we want to find g, and that is reflection in the y-axis. So that means x becomes a negative x. So I'm going to write down y is equal to an inner bracket that x becomes a negative x. But remember, in your domain, that x also becomes a negative x, and that the range will stay the same. So now we can say, if we simplify this, that y is equal to x squared, and x will be less equal to 0 because we divide with a negative, and y will be greater equal to 0. And then we can write this in fx notation. So we can say that gx will be equal to x squared, and x will be less equal to 0. So as you can see, that graph is clearly the one that will go here, because that is also for all the x values less than equal to 0. So it's for these x values. So there we've got the reflection of f in the y-axis. Let's now look at the next question. In this number 2, they ask us to determine the equation of the inverse of g. So they want us to find the equation of the inverse of g. We just found g in the previous question. So I'm going to say that for g, y is equal to x squared. You remember that's what we said. And x was less equal to 0, because remember g was a reflection in the y-axis of function f. And we can say y greater equal to 0, that is the range of g. Now for the inverse, we interchange x and y. X becomes y, y becomes x. So we will get x is equal to y squared, and we're going to interchange it with the domain and range as well. Remember, always x becomes y, y becomes x. So that means the domain becomes the range, and the range becomes the domain. So we will get y is less equal to 0, and x is greater equal to 0, because that x becomes y, and that y becomes x, the same what we did here. So now we're going to write down y. So y will be equal to plus minus the square root of x. Now, we know from our domain and range now that y is less or equal to 0. So that means y is negative. And that means we only use the negative arm of this function, because plus and minus means it's both arms, and we only have one of them because the parabola was restricted. So we can now say that the inverse of g is then negative the square root of x. So it's the negative arm of the inverse that we are working on. That, and the reason for that, again, because we know that y must be less equal to 0 and x must be greater equal to 0. That's domain and range. In the next question, they ask us now to sketch these two functions. They want us to sketch g, it is that one, and they want us to sketch the inverse, that is the one that we just found together on a new set of axes, and we must show the line of symmetry. So let's now find coordinates like we did in the previous question as well, and then we can sketch them. So I'm going to say that gx is equal to x squared. And remember, x is less equal to 0. So when I select x values, I only select x values less than 0, less or equal to 0. So I'm going to use 0, and I'm going to use -1 for x and -2. So I'm using 0 and negative values because x must be less equal to 0. When I substitute 0 into x squared, I will get 0. If I substitute -1 into x squared, I will get +1. And when I substitute -2 into x squared, I will get +4. So now we're going to write down the coordinates for the inverse. So our inverse of x is -square root of x. We don't need to do any calculations. We can just interchange these three coordinates. So the first one will stay the same. The second one will become 1 and -1. And the third one will become 4 and -2. And now we're going to plot these points and draw the graphs. So let's start with the parabola first. The first point I'm going to plot is 0, 0. And then at -1 and 1. And then the next point is the point at -2 and 4. So that is 2, 3, and 4 at -2 and 4. And as you can see, that parabola will go right here. And we're going to draw that graph now. So there you can see the graph of gx. And that is gx equal to x squared. And it's only for negative x values, x less equal to 0. Let's now plot the points for the inverse. And it's 0, 0. And then it is 1 and -1. And then it is -2, -3, and -4. And then this point will be 4 -2. And it will be over there. So as you can see, this inverse graph will be right there. So I'm going to draw that now, and also the line of symmetry. So let's do that. So now you can see the graph of the inverse. That is the graph of G. That is the inverse of G. And that is the line of symmetry, the line y equal to x. And with that, we are finished with this drawing. Let's now look at the next question. This is a new problem that we're going to do in the example 11. And this question say that the sketch alongside shows the graphs of G, the inverse of G, and H. So if you look at this drawing, you will see the graph of G right here, the graph of the inverse of G, and then the graph of H. So the drawings are given to us, but we don't have all the equations. They only gave us the equation of gx. Now this is a parabola, and it's a sad face parabola because of the fact that this a is -1/2. But take note of the restriction. The restriction is x less than 0. Equal is not included, so that is very important. Naught is not part of it. And if you look at the drawing, you can see there's a little open circle to show that 0 is not part of the graphs. Now they say to us that H is the reflection of G in the x-axis. So this H and G are one another's reflection in the x-axis. Now we know what G is, so we expect they're going to find us to find H and also the inverse. So let's look at the first one. The first one say write down the range of G. Now to write down the range of G, we need to, in this particular case, we can just look at the drawing and it's quite easy to see. If you look at the function G, you will notice that my domain is x less than naught. That is what is applicable for this graph. And the range, these y values. But take note, excluding 0. So all the y values less than 0. So that means we can say that the range of function G will be y less than 0. So it's only for negative y values this graph of G is defined. In B, they ask us to find the equation of H. Now, to get H, we need to go back to our given information where they told us something about H. And they said that H is the reflection of G in the x-axis. So I'm going to say that for G, because that function was given to us, y is equal to minus a half x squared. And remember, x is less than naught, and y is also less than naught. That's what we said in the A part. So now for h, because we are looking for function h, and h, remember, the reflection in the x-axis, so that means y becomes negative y. So this y will become negative y equal to minus a half x squared. And then x will stay less than 0, but this y will also get the negative there. So now we can just simplify this, and we multiply both sides with minus 1, and we get our y is equal to a half x squared. You can see that is already happy face. And our domain is x less than 0, and y must be greater than 0 because we divide with a negative. So that means that hx is the function a half x squared, where x is less than 0. So for all those values. So as you can see, when you look at the drawing, that is exactly what this h looks like. So you can see that x is negative, all x values less than 0, but y must be greater than 0 now. And that is that y greater than 0, the range of h. They now ask us in number C to find the equation of the inverse of G. Now remember, G was given to us, and they want us to find the inverse. It is now the equation of this one we want. So let's just do that. So I'm going to say that for G, y is equal to minus a half x squared, where x is less than naught, and y was also less than naught for G. Now, when we look for the inverse of G, we interchange x and y. So we will say that x is equal to minus a half y squared. And we must interchange the domain and range as well. So y will be less than naught, and x will be less than 0. So now we can say that y squared is equal to minus 2x, and that means that y is equal to plus minus the square root of negative 2x. But as we know at this point that y is less than 0, so that means we want the negative arm again, because you can see this inverse is below the x-axis, and that is because y is less than 0. So it means we can now say that the inverse of G is then the negative root function of minus 2x. But very important to remember, x can't be 0. X is less than 0, but not equal to 0. And that is the inverse of g. So up to here, we now found already the equations of h and the inverse. Let's see what they want us to do in the next question. In this question, they ask us to calculate the coordinates of P. Now, if you look at the drawing, you will see that is where P is. And P is the point of intersection between G and the inverse. They also intersect at 0, but remember 0 was not part of this function. So we want that point of intersection. Now, like we've done before, we're going to do simultaneous equations, and we're going to look at the G function, because I think that is the easier one to use. So I'm going to look at gx, which is equal to minus a half x squared. And I'm also going to look at y equal to x. You remember from our previous discussions, we said that y equal to x intersect the function and the inverse in the same point of intersection. So it is much easier to use y equal to x instead of the inverse function. So let's now put them equal. So we say minus a half x squared is equal to x. And then we will manipulate, and we get that x squared is equal to minus 2x. I multiplied both sides with negative 2. And now we can write this as a quadratic equation, and we can factorize to solve for x. And that is x plus 2. So now we can say that x is equal to 0. And this one, as you know, is not applicable because 0 is not part of it. Or we can say that x is equal to negative 2. Now, if x is negative 2, because one of the functions is y equal to x, that means y will also be equal to negative 2. So now we can say that coordinates of P will be minus 2, minus 2. So those are the coordinates of point P, the point of intersection. Let's now look at the last question. Now, in this question, they ask us to find x if gx is greater or equal to the inverse. So gx greater equal to the inverse. You can see this is a relationship between two functions. And you remember during our grade 11 lessons, we spoke about those, that we draw these vertical lines where the two graphs intersect. Now, the two graphs intersect, as you can see, at point P, which is at minus 2, minus 2, and at 0. Now, 0 is not included in this particular drawing, so we only need to draw one vertical line right here. And then we have the two intervals to check which one is the one we're going to use for the answer. So there is my vertical line. And when I look to the left of this vertical line, so to the left of point P for those values, there you can see the inverse is above the G. So G inverse is above. We want G to be greater than the inverse. So you will agree we don't want this part. Now we look at this interval between the minus 2 and 0. Minus 2 and 0. So we're going to look at that. Now, when you look at this little interval from minus 2 to 0, you will see that G is above the inverse of G. So that is what we are looking for. So we're going to write down our answer, but please take note, equal is also included. So we're going to include the negative 2, But please remember, we can't include 0 because 0 was not part of the domain given to us. So the solution to this question is -2 less equal to x less than 0. So if we read from x is greater or equal to -2, greater equal to -2, but less than 0, but not equal to 0. And that is the solution for gx greater equal to the inverse. Thank you.